ultimately, you have to do your graphs for this lab in Excel. The good news is, because of that, you can make Excel do a lot of the heavy lifting for you and make this go a lot faster. For example, let's say you've written down you measured your ticker tape distances, and you've written them all down in centimeters. And so your distances look like this. Actually, it wouldn't be 2.53 centimeters, would it? Yeah, it would. And 4.1. I'm just making numbers up, obviously, but let's say it looks something like this. Well, but what are we going to do with those distances? Well, for one thing, we want them to be in meters instead of centimeters, right? And so you can just make a formula to do equals A1 divided by 100. Whoa, not A10. Wow. And then just fill down. Oh my God. Right? No. And then that just converted from centimeters to meters, and yeah, it might be helpful to do titles, right? So distance in centimeters, and then this is distance in meters, just so you don't get lost in where you're going. And then, what else are we going to do, bless you? Yeah, we need to know time. Whoa. And what period of time elapsed between these distances? A 60th of a second, right? So again, I could type in, calculator, use, find out what 1/60th of a second is, or I could say, hey, this is Excel, so I'm going to say equals 1 divided by 60. And there's your 1/60th of a second. And I'm going to fill down because all the times are the same, right? Between each dot is 1/60th of a second. So now I have distances in meters and times in seconds, and I can find the average velocity for each of those times, right? So I can say velocity in meters per second equals what? V2 divided by C2. And then again, use the fill down. For the formula per second, that is equals 1 divided by 60, because I know it's 1/60th of a second. And then I just took that distance divided by 1/60th of a second to find the average velocity in meters per second.
What's to write down for the velocity?
I'm sorry?
The direction? Do you have to write direction?
Good question. No, it's technically we're finding speed. So yeah. But yes, the direction is down. Good question. Since I'm graphing it, I'm not too worried about it. If I were like doing a table or something, then I'd be worried.
Do we have to do this for 500 milligrams, 200, and 100?
Right.
So
yeah,
we make like a different section.
We're getting there. We're getting there. So I got my velocities, and I'm going to do a graph of velocity versus time, but not this time, right? This was just the time between dots. I need velocity versus a cumulative time, right? After 1/60th of a second, after 2/60th of a second, after 3/60th of a second. So to do that, I just need to have the trial numbers. So I'm just going to put a 1, and then I'm going to fill a series. So that I do steps by 1, right? Step value 1. And I'm going to stop at, in this case, 5. You guys are going to have more trials. I'm just doing an example. Oh, shoot. Undo. forgot to change it to columns. I want it to go down the column from 1 to 5.
Why not 6? Oh.
Why wouldn't you just type 1?
For you, it's going to be 10, right? Because you're going to have 10 trials. So I'm just doing an example arbitrary. Okay, and why do I do that? Well, because ultimately I want a graph that has what on the x-axis? Time, total time, right? And what on the y-axis? Velocity, average velocity. So I'm thinking ahead. So right here, the only thing about Excel is it's always going to assume that the first column you list is the x value, and the second column you list is the y value. There's ways to work around that, but the simplest way is just to set it up that way. So I'm going to make this my x column. And what's it going to equal? It's going to equal however many 60ths of a second have passed. Well, how do I get that? I say equals C2, which is a 60th, right, times what? E2, which tells me which trial, or which dot. So when I fill down on that, guess what I get? That's 1/60th, 2/60th, 3/60th, 4/60th, 5/60th. Oop. Oh. Well, that's one of the reasons I'm recording it, so you can go back and look later.
Well,
Okay? And then what's this? The velocity in meters per second, which is just equal to d2, and fill down, and so it's d2, d3, d4, d5, d6. See how these velocities, which were the average velocities, are now the y value in my table here. So now, I'm just going to highlight all my data, and I tell it to make a graph for me. So I'm going to go to Insert, and I can choose what kind of chart I want. Always, 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 in this class, choose XY scatter. And we don't want any of the lines or anything. We're going to take care of the line in a second. So I pick that one, and there we go. Now I have a graph of this on the x-axis and this on the y-axis. So what's missing from my graph now? Who? Lines. So I need a best fit curve. We'll get to that in a second. What else does every graph need? Good. A good title. And so I'm going to go to the chart layout. And right here it says chart title. And let's say I'm going to go above. And chart title is a really lousy title, isn't it? What would be a much better title for this graph? Excellent. Velocity versus time for,
500, 100.
okay, for falling masses. And again, you can change this, but I'm just giving you some ideas.
Wait, but what is
Wait.
that only for one falling mass?
Okay?
It could be like 50 or...
Yes, I could. If I want to do an individual graph for each mass, then yes, I could say for a 50-gram mass. The other option I have is I can make series where I have all three graphs or all three masses on the same graph.
Oh, and so you make the dots like a different color for each one?
Right.
And then you have to have a key, though.
Yes.
The velocity one doesn't have to be straight.
Well, we'll see. I mean, in this case, I just made up these numbers, and so it's not real straight, but yes, it should be. Okay, and I'll show you how you can fix that in just a second. Yes?
So, like, if you make another one, like, how do you change, like, the little key on the graph?
Alright, we'll get there. So let's do this. Let's do falling masses and end up doing all of them on the same mass. Or on the same graph. What else is needed? Huh? We need
So the axis.
axes labels, right? What's the label on the x-axis? Time, just like that.
Second.
And the unit, seconds. Good. And then same thing for the vertical axis. We're going to do rotated. It's easier to read. And what's that going to be? Velocity in meters per second. Okay? So, all good graphs, you should have learned this starting in freshman biology here. All good graphs have an appropriate, a good title, clear title, which is almost always y versus x for whatever the trial was. Labels on the axes with units with those labels. Fill the page, right? And Excel is going to do that for you. It's going to do your scale so that it's not clumped up in one corner. It actually fills the graph. And then what's the last thing? A key if you have multiple trials on the same graph. But if not, you don't always have to have that. You always have to have a best fit curve. Alright? Now, a best fit curve is not connect the dots. Don't play connect the dots in here. A best fit curve comes as close to as many data points as possible. When you're doing that by hand, that means you line up your ruler and you try and find either a straight line or a curve that comes as close to as many points as possible. In Excel, we can make it do it for us. The way we're going to do that is you click on a data point. See how now all the data points are highlighted? Right click and say add trend line. When you do that, it's going to ask you, hey, what kind of trend line do you want? Here's the point Chaz just brought up. What should this fit be? It should be linear. So we're going to force it to be linear. Now, if the relationship was quadratic, if you had y equals something x squared, then I would choose a polynomial, second order polynomial relationship. But in this case, I want linear. Alright? And then these two boxes, always, always, always display the equation and display the r squared value. Okay? And then we're done. And then I can drag this box over to the side to where it's clearer to read. But see here, it tells me the equation. It tells me the slope of the line is 39.8 meters per second squared. And the r squared value. What's the r squared value? It's a statistical term. Basically what it means is how close are the data points to the best fit line. If every single data point actually is on the line, that's an r squared value of 1. The farther away your data points are from the best fit line, the lower your r squared value. So 95 here, 0.95 is very good. It's reasonable. You shouldn't get 1. If you get 1, I'm going to accuse you of making up your data. I mean, you may not have made up your data, but it looks very suspicious if it's actually 1. So just be aware of that. So don't expect 1, but want it to be close to 1. Alright? Now, let's see if we can add multiple series on the same chart. And so if I go to select data source, then series 1, we're going to edit that to call it the 50 gram mass. And so there you go. I'm going to add a new series, and I need to tell it what it's called, the 100 gram series. I need to tell it where to get the X values from. If I click, and then I can just drag it over the X values for the 100, for example, and hit enter. And then for the Y value, same thing, and enter. And then if I had actually had numbers in this box, right? Oh, and okay. These should be the same number as those, actually. So I can just copy and paste that. Whoa, sorry. No, I can't, because it smart entered them. Hold on. So that's equals C2 times E2, and then do the fill down. And then if I had done if I'd punched in, you know, the distances for the 100 gram mass over here, and then the velocities would end up like in K, and then I could put them here. I'm just going to make up numbers so that you can see it happen. 2, 3, 4, 5. See how it's now adding the second series to my graph? But what does it need? It needs a trend line, and so I'm going to add trend line again. Make it linear, display equation, display R squared, and close. Now, you can. I don't care if you do 3 separate graphs or if you do them all in the same graph. The way we did the first series is how you do it if you're doing separate graphs, but I wanted to show you how to do it all in one graph in case you wanted to. The only thing you have to be careful of on one graph is this. The legend will show you, either with color and shape, which line belongs with which mass, but these equations that it's putting on here aren't color-coded or legend, or they're not keyed to the legend. So just make sure you drag them close enough to the line they belong with, that I can tell which equation goes with which line.
Can we just make the text the color of, like, the series?
Sure, if you're going to print in color, absolutely. Okay? And then, honestly, we don't have to display the labels of the trend lines since you can do it that way. If you wanted to, you could change them up, and I guess you could do it that way, but yeah. Questions about this?
Are we doing that here?
You may start here, absolutely. You can grab something off the laptop cart if you don't have your own. Hopefully you have a thumb drive, but you can also save it to the iDrive, your iDrive from there. Yeah.
Do you have a